Alright, hello everybody. I'm gonna turn this on a little bit. No, sorry, turn it on a little bit. Okay. Alright, hello. Welcome back. This time we're on a Wednesday afternoon rather than Saturday night. I think this will work out a little bit better. 1 second, just still getting a little bit set up here. Where is that app? There it is. Okay. Guess I could have used that as well. Oh well, whatever. Alright. So, today we are welcome back to a live stream. Okay, so let's start off today. We are going to show off, show and tell, I guess. Here we go. All right, let's see here. Oh, laser tag. Yeah, that's right. That was supposed to open up. I don't know. Open up. All right. Anyways, we're just making sure that we got everything set up correctly. There we go. Also looks like that the audio filter might be working. That's good. For once. Alright, here we go. Alright, cable input. Nope, not that one. The other one. This one, okay. Listen through ear output, okay. Wait, then what does Discord go through? Oh wait, no, that's right. There we go. Huh. Virtual microphone. Listen through headphones. No, listen through rear output. There we go. Okay. I'm gonna join a discuss. We're gonna start this off. No, I'm not gonna do that. I just have to play the music. Alright, I'll figure out Discord next week. Okay, so let's see here. Laser tag, I guess, big summer project that we're doing. Over here at Quantonium. Let's sure we got shuffle and random loop on. Alright, so here we go. I want to open up this because we're going to be talking about gameplay abilities, and actually just today got working the main gameplay ability of this game. So here we go. This is a little test map right here. And I, by the way, was working on this in C++, so we can actually quickly open that up. But while that opens up in the background, I'm just going to click play. We have a little... There's quite a bit actually going on the screen here. I'm going to break it down to you a little bit. So go over here, separate this view. As you can see, we got 2 players right now. So this little window over here, this is just the other player, and they move around. As for why it freezes, I'm not entirely sure why it does that. It's an issue with Unreal Engine. I think. Yeah, definitely something's wrong with that screen. So if we... I'll just close it. There we go. Alright, you know, I had that working today. I swear. What's going on? Really? It's broken again? Alright, so, what's... What's going on? Okay, so what's supposed to be happening is that these blue spheres are supposed to be lined up together. Pretty much one is the server, the one that's staying still, that's the server side. And then the client side is the one that's moving around. It's linked to the skeletal mesh. And it's supposed to be linked together, but apparently the changes that I made didn't go through or something. let me check that real quick. So let's look at some C++ code. Yeah, all right, here we go. So we got it's player character. So I believe we looked at our own player character in the mobile game a few weeks back. The function that I'm looking for is the constructor. So the C++ code is a bit different, excuse me, than the other code, the blueprint code. So I'm looking for specifically that function right there. Okay. Did I not push changes? All right. So a little tip with SVN here. So I'll open up. This is the laser tag project here, and I'm not sure about a change that I recently made. So I'm gonna go here. I'm gonna right click. I have Tortoise SVN installed, so that's the SVN client that I have. And then I'm going to go to the. Let's go to the check for modifications, I guess. All right. So we got a bunch of binaries that are checked out. Let's try revision graph. Okay, the revision graph doesn't work. Trying to look for a way to view the commits locally without having to go in and view the online. Here we go, the log. That should work. All right. So this is the change I made. You can look at the file. So the file in question is playerCharacter.cpp. So show changes. Okay, and then these are all the different changes. So okay, now so it's this line that I was looking for here. This line should be present in the code. That should be a thing that fixes the animation syncing between the server and the client. So player character, let's see here. Let's check out the line is still there. This is line 75. It is, and yep, it's right there. Not sure why it's not running then. Something I have to look into. But okay, it's running now. Wasn't running before. So now that's running. If I shoot the laser, as you can see, text is still showing up. Why is it? Thought I commented out all the text. Maybe I didn't, huh? Let's check that. So base weapon, it is in. And then debug message. Yeah, so it's not there. I need to recompile. Oh boy, it's a lot of Action Studio 16 with only 8 processes. If you're looking to doing C++ with Unreal Engine, by the way, definitely recommend to get a good CPU, because compilation can take a while, especially for large projects or like with a lot of plugins. All right, there we go. Let's see here. That should probably hopefully fix things. Yeah, this looks a little better. Okay. So I was running a little bit of outdated code and the engine crashed. Great. Okay. This happens sometimes. I don't know what that error is. I got it earlier today, but I don't think it's anything important. I think it's just engine bugged out or something. Definitely worth looking to and testing out, but not quite there yet. All right. Anyway, so yes, what I was gonna focus on. We're gonna not worry about that. Go back to laser tag. We're gonna reopen that map. Here we go. All right. And it's using outdated code again. What? Alright, so if it keeps doing this, one thing that you can try doing, so you go into here, see the binaries folder, and we just permanently delete that. Yep. And then realize I can't delete it because we have Unreal Engine open, so we'll just recompile real quick. Where did the compilation window go? Alright. Anyways, so I'm gonna build this real quick in the background. Oh wait, there it is. It's open in the background. Okay. Anyway, so the point was with that, got a little overview of some of the features Taurus SVN has to offer, but also what I wanted to show you was the gameplay feature or the ability that was implemented. That is simply the ability to shoot lasers. That was what I worked on today. Command finished. Exit. What? Build. Alright. Visual Studio is broken. Okay, there we go. Whatever. Won't worry about that. Alright, so yeah, that's the ability, and then the ability. Let's open up our good old OneNote note-taking app. Alright, so this is our level design from last time. Looks like a bunch of squigglies, and if you weren't there for last live stream, probably looks like a bunch of squigglies still. But trust me, we go over each different part and each different section, how we sort of build the map out in that live stream. So this live stream, gameplay rethinking, that's what we are going to be focusing on. So let's go back to our very first one. Here we go, development and design. Nope, not that one. This one here. Yeah, so here we go. So yes, the ideas change over time. So we have our basic initial idea of a mobile version of laser tag. I think. Hold on, can I open these in like split view? That'd be really nice. So I think. Oh yes. All right. So I think. Therefore I am. Now I think that we'll start off with laser tag on mobile. There are 2 cats right now playing in my room. And running up onto my legs and stuff. Alright, so I think laser tag on mobile is not super viable because if we look at, kind of close that real quick, we're going to look at our live game here. There we go. Oh yeah, there's some changes that I made to the live game, so we'll go over that really quick, okay? No, we won't go over that real quick. We'll go over what we're going to be doing currently, but as you can see, there definitely are some changes. Oh, that's some like global illumination. That's interesting. I'm wondering what the weird white shadows are. Okay. So anyways, this is more or less what we have from last week, except as you can see, there's now shadows working. So I finally got that sort of worked out. And also the play reveal system by the wall now more properly works, and I'll sort of go over how that works. It's not too difficult. If you know what a projection is, then I pretty much should just do that with the camera. But we'll go over more in detail with that. Anyways, with this game and with laser tag, so let's look at the map here. The point of laser tag is to be able to shoot a laser that like bounces off the walls and stuff. And there'd be like mirrors here. So like this block here could be like a mirror. So let me just create a quick mirror material. So we go to map and then we go, I'll create a new material. Mirror test. There we go. All right. If you want to create a mirror material. So first off, let's put the base color in, give it black. And then metallic, full metallic, I think, if I remember correctly. Roughness 0, and then specular should, I think, be 1. Let's see what that looks like. So it's preparing shaders, and no, not quite. Okay, let's see here. 0, nope, okay, let's try white. There we go. So there's this nice shiny reflective material. Could probably turn on the metallic or something, I don't know. That's like shiny plastic material. Alright, anyways. So yeah, we now have a nice little metal material, so we can apply it over here into this random wall here. If we do that, then it's going to prepare shaders again. But yeah, that would be sort of like how this would be a reflective wall. The reflections don't really work because well, actually that's another issue. So all right, first issue with laser tag on mobile, super viable, no. First issue, you can't see all the walls with top down view. So maybe we could change it so that's more angled on the top of the play or something like that, but I think I like this little view better. So I don't see any reason we're going to change it really. But this does come with the issue. As you can see, I can't see any of the back walls, so let me eject here real quick. I can't see this wall. I don't know if this wall has like a mirror or a window or I don't know, something else. I can see here, yeah. But this is, of course, another issue. So we'll go over this issue now. So reflections don't work well on mobile. So that's just simply an optimization issue. Now, that isn't to say reflections can't work on mobile. So let's turn on the Vulkan here. There we go. Oh boy, that's kind of weird. What's going on with that shading? Alright, so if your lighting ever looks sketchy, huh? Okay. If I click play, okay, that looks wrong. I do not know. I don't know what's going on, honestly. With this is weird. Okay, now it's gone, huh? Probably just some issue with cached lighting or something. I also don't see any shadows. Really? I can't build the lighting? Okay, I guess we'll turn off the Vulkan preview, because that didn't really work. I'm going to here. Yeah, project settings real quick. Let's check to see our settings for platforms. Okay, so we have sorry, there we go. I'm just finished that. All right. So the thing that I saw there was that it required shader level SM5 at least for baked lighting. So we have the Android here. These are just Android settings for building the game onto the platform, but I believe somewhere we're gonna have rendering settings as well. Maybe. So in Windows we have right up here the shader formats. This is, hold on, shader model 5, clear, yeah. So less than shader model 5, what? I'm not sure what's going on there. Alright, anyways, so back to why reflections don't work. This is what the, let's go into the, so there's a nice view mode called reflections here. And we can see that this just does not look correct or whatever. Oh, that's weird. There's a weird thing going on with the materials. Anyways, so yeah, the reflections just aren't working out here. Now there's a way to make them work out. So let's go back into the lit mode here. We go into our visual effects and we take a reflection capture. Now the reflections sort of work. You can at least see, like, you know, look at that. Look, there's walls there. If we resize the box here, you'll actually see that it fits a little bit better. So to resize it, we just need to scale it around. So make it a little bit smaller. There we go. And then let's make sure it's not in the wall or in the floor. There we go. We'll raise it up a little bit. Okay. Let's go back into that reflection view mode. There we go. Now I can see what it sort of does. Oh boy. Actually did a lot more than I thought. So what it did pretty much is take a snapshot of the scene and sort of flip it around. So if I go over here, thought there was a way to resize it manually, but okay. So yeah, it takes a screenshot of the scene and pretty much puts it onto the objects. That's what the reflection capture does, and that is more kind of what a reflection is. Anyways, that just doesn't really work out that well, so let's stick with minimizing the total reflections that we got. Alright, optimization issue doesn't look good also. Yeah, so with that, I think I'm going to be cutting lasers. Cut lasers from game. What we are going to be keeping though is a lot of the other stuff. So it's still going to be multiplayer. We're still going to get that out of the way. I'm going to keep the map layout and control scheme sort of the same. Now, what we're going to add are gameplay abilities. So I think there's still, I still want to go with, you know, lasers. There's a good thing about lasers. They bounce off of walls. We could still incorporate that into the game. So what I'm thinking of is shooting projectiles that bounce off walls. And then, ooh, actually that could be even funner. Maybe, so, you know, on a basic, these projectiles, when they hit equals damage. That's fairly basic. But what if instead we can do like a paintball style? That could be interesting. One thing about the paintball is that it could be kind of difficult to optimize, especially on mobile. Getting a lot of different like paint decals to show up on the materials here can be kind of a challenge to get working, and I'm not entirely sure how to do it right off in Unreal Engine, but I'm sure there is an optimized way. I did something similar in like a VR game, not a VR game jam, VR game that I made for a game jam a few years back. Pretty much drawing markers onto any object in the room, and that was really poorly optimized, mainly because all the objects could move around. So I do not recommend doing that. I think we're gonna probably not in this live stream, but probably later on, look more in detail into how we can sort of get that sort of feature working. That could be a interesting feature. So, anyways, if you notice in the title of the stream, it is gameplay abilities and features. So I'm gonna add feature. Now what? Gameplay abilities and objectives. That's right. So the objectives would come into the defeat player. The objective would come into the idea of defeating the players. Alright. So there we go. What we're going to be pretty much doing today is we're going to make this sort of projectile that can bounce off the walls. We're going to make the player shoot it as well. And then maybe we'll also do some basic collision testing or something like that. Oh, excuse me. Let's get started. I'm going to put on my glasses real quick. And then I'll show you some of the changes that I did to fix things up in the project that I mentioned before. So, oh boy. Alright. There we go. Alright. Oh boy, my glasses are kind of foggy. It's annoying. They're really foggy, actually. Alright, so let's get started. Come on. Where do I come off? Oh, that's really dirty. Why are my glasses so dirty right now? Okay. So the very first thing that I'll talk about while trying to get my glasses cleaned is how I got the shadows to work. So I figured that the walls and the obstacles and whatnot in the game, well, they are all static objects pretty much. They're not going to move around. As far as I can tell, the walls aren't going to move around. I mean, later on maybe we could have moving walls, but that's sort of a more complicated thing to do. Alright, here we go. Anyways, and by default, when you add, say, an object here, so here's a cube, by default it is, oh no, it's stationary. Okay, so if I go into the modeling viewport mode and I add a box here, and I just click accept, I save it here, I'll just as a temporary location. As you can see, it's by default movable. So let me delete this. Here we go, we don't need that. So let's go here. Let's read what the description does. Movable, totally dynamic, casts a dynamic shadow, and is the slowest to render. Now that's a key thing there, is casting a dynamic shadow. That means casting a dynamic shadow means pretty much in a technical term that it can't use shadow maps for the object's own shadows. So if I click play here, this shadow is moving around, as you can see, when I rotate the turret that we made last live stream. And also when I move the character around, the shadow moves with me, as you'd expect. It also goes up onto like different walls and stuff. So it works like as a shadow, pretty much. Now with these objects, actually, you know, let's turn this into movable. See if the shadows still work. Oh, they do. Okay, so if you turn a bunch of them onto movable, it won't work anymore because there's too many objects to make shadows for. Too many what are called shadow maps to build for all the different objects. So that's why pretty much our shadows are missing previously. But now we do have shadows because we set everything to static. So static allows for baked lighting. The difference between the shadow maps, real-time shadow maps, and the baked lighting is that these shadows are pretty much pre-computed. So yeah, the shadows are pre-computed. They are pretty much put onto an image, more or less, designated for, let's say, the floor here. So this box here is the floor. And oh, you can kind of see it down here, how the shadow maps sort of work out. So it just creates an image representing the shadows generated by all the different objects on the world. And then when you click play, we'll click play here, there we go, and the shadows can still react. See, on our own character, the shadow is still showing up there. That's because the character all needs to do is just access that shadow map, and get like the world location, and then based off of that it can indicate whether or not it's in the shadow without having to recompute that shadow map image every single time. You just do it once and then you just pretty much forget about it actually. And that's something that Unreal Engine does on its own, by the way. And then the last item there is stationary. So stationary is a sort of in between static and movable. What stationary does is allows for it can't move around physically in the world level, but you can have it change in some manner in the level. So let's say we want this random wall here to be flashing like a red beacon or something like that. Obviously when it's flashing red, it's not going to be casting shadows necessarily. So the stationary mode would work out with that. Like if you have like a stationary light, then ideally you can set the object for that light to be stationary. And actually regarding lights, there's a few more fancy rules with them. With the stationary, static, and movable. I believe I may have went over it when we started making the map initially. Pretty much the stationary directional light allows our player here to get shadows. If we set to static, I believe the player gets no shadows. Also, we need to rebake the lighting. So because we're using static lighting, we just go over here, build lighting only. This might take a while depending on your computer and also depending on how complex the level is. There we go. Okay, that was pretty quick. And it broke things. That's kind of weird, but anyways, as you can see, I'm not sure when the road's going on, but our player doesn't have shadows pretty much. So if we switch it back to stationary, oh boy, those shadows are really light, but they're there. Probably have to rebake the lighting again, so do the same thing. There we go. Alright, so yeah, that's pretty much sort of fixing the lighting up. There we go, we got our shadows back. Alright, next thing that I changed, if we go over to the wall here, as you can see, now we see the player all the time. It's before, you can look back at the previous live streams. The system that we had before for this sort of detection, it covered up the player when they neared the wall. So let's go over how that works. So out of bounds mat was the material that we have, and it's a relatively simple fix really. So I used the project vector onto plane right here. So in case you don't know what a projection is, let me search it up. There we go. Vector projection. Let's look at images to see how it works. Alright, so what a projection does is, in this example, we are projecting, I believe it is, hold on. Okay, yeah, I think we're projecting the A vector on projecting the... Okay, no, this is... Let's look at the Wikipedia page. Screw this. Okay. Vector projection. Description. Projection of A onto B. Okay, so the projection pretty much, if you take, let's say, here we go, I got a phone here. Alright. So I got a phone here. There's a surface on the phone. Now, let's say I want to take a picture of my water bottle here and then display it on the phone. Now, this water bottle is a 3D object, but my phone's surface here is flat and it's 2D. So what a projection does is it allows me to take the 3D object and pretty much put it onto the planar surface of the phone. So you can think of the phone as a vector, where, let's say my finger is the normal vector. So that vector represents the phone surface, planar surface. Now then, we can take the water bottle. So the water bottle is, let's say, a bunch of points or vertices in 3D space to make the object of the water bottle. I take those points, so let's say the location of the water bottle is right here. That's in 3D space. I take the points and then I pretty much sort of cast them. I might draw a line. So here's like the water bottle here, right here. And then there's a line that goes onto the phone plane. And then wherever it ends up on there is the resulting vector. So it pretty much takes one sort of transform space and then puts it onto a different sort of dimension or different space. Yeah, sorry, I'm kind of bad at describing that, I guess, but that's more or less what projections do if you don't know how they work. Very important thing with 3D graphics and also games in general. They can do stuff such as helping out with detecting the angle of collisions on the ground, I believe. They help out with, obviously you might have heard of projecting things into 3D space, or like an orthogonal projection, for instance. That's like converting the points. In computer graphics, actually, like right here, this window here is represented, the sphere is represented by a bunch of 3D points, and you essentially have to project the 3D points onto the 2D surface of the screen. So that's sort of where projection goes into play, and that's pretty much what I'm doing here. So I'm projecting our world positions here, so the player position and then the absolute world position of the current pixel, projecting them onto the camera direction vector. So you can imagine like before, how on my phone I had the normal vector, which was represented by my finger. You can do the same thing with the camera viewing plane pretty much. So the camera direction is essentially just that normal vector. I projected the world position onto the normal vector to get sort of the camera position, the position of like these pixels on the camera. So then with that, I instead use that sort of distance length comparison rather than comparing the position of the world object to the position of the player. Now it's relative to the camera, so the projection will help out and make sure that the player is always visible. No matter what angle the camera's at, no matter where the player's at or what they're behind or how thick of an object they're behind, that'll always be visible. Alright, and then one more thing, I'm going to go into unlit mode here. One more thing that I added, real simple, is I made some optimizations here, but one noticeable thing is that I added a ground floor here so that when the camera does clip through, sort of like what it's doing right here, actually this is sort of how the projection works. So by default the vector is at 0, 0, 0 right there, so I can see the center of the world thanks to the projection change that I made. Anyways, so yeah, what I did was I added this bottom floor. I pretty much just copied the top floor. So I selected, all these walls up here, and I alt dragged them down. Oh boy, I selected something else. I'm not sure what went on there, but pretty much, yeah, I'll drag them down right below the walls, the outbound walls that we had before. And then I also made a material here, base mat out of bounds. All this is just an instance of the base mat, but made black, to sort of give a little bit of floor in case the player ever sees what's underneath the wall. And then one more thing, for like in terms of optimization, so I'll do it here, right here, as a sort of example, and replace this with that there. All right, click play, and then if I go over to that wall over there on the other side of the map, here we go, not too slow. All right, there we go. All right, there. I can't really see it. Huh, okay, never mind. Okay, you can't see it there, but if we do it here. What about here? Okay, there we go. Try it again. And then click play. We go over to here. There we go. We see it. We see it. Oh, you can kind of see it. There we go. Yeah, see that right there? That little blip right there? That's because the wall would actually be visible as you move the camera around. So you can see it there. Oh, wow. That's a cool tunneling effect, by the way. Huh. Actually, it's, camera direction is not exactly accurate, it seems. Or something. I don't know. Alright, anyway, so what I did was I made a no render material. All it is a masked unlit surface material with the opacity of 0. So it just hides the surface here. And then I set it to all but, you know, one side here. And then I also had to rotate these so that you don't have like an invisible wall. If I rotate it in like right there, then that breaks the game. That's an invisible wall. If you were doing source map making, that would be called leak, by the way. Anyways, so yeah, that was the changes that I did more or less here. Alright. So with that out of the way, let me save everything there. There we go. I'll save our 2 materials. Yeah, mirror test will just keep that. Might use it later on. One thing I'm gonna do is make a separate player material. So player, alright, there we go. Alright, let's have player base matte. Alright. Here we go. Make a simple or red or something like that. There we go. Convert that to a parameter. Base color. There we go. Alright. Try it to the base color right there. Alright, good job. Now once it loads, alright, there we go. There's our shiny red material. Now let's modify a little bit. So roughness, let's give let's do like half rough, half smooth. And then do full specular. I don't think. Oh yeah, it looks kind of nice actually. It's like a plastic material. Looks like a plastic ball. All right. There we go. Save that. Okay, there we go. Now I'm gonna make a player Canon matte. It'll be a separate material. Actually, no, it won't be a separate material. Yeah, no. We're gonna delete that actually. So delete that. There we go. We're gonna back into this. Convert these to a parameter. So what is a spec? We're gonna go a separate scalar parameters rather than doing a combined vector parameter, because what you could do is take the red, green, and blue channels and you could like drag them in, for instance, metallic right there. That's perfectly acceptable to do, and it will save on like total parameter space used, but just for simplicity, I'll keep it here. So do metallic, there we go. No metallic by default, and then also do for emissive, do a 3 vector, convert that. You can also hold on the V key and click there. Emissive color, there we go. Put that into our emissive, and then actually we're going to do something different. We're going to multiply by a scalar. So I held on S and then clicked. Emissive brightness. So set this to default 0 because we don't have any emissive, and then just add that to the emissive color, and there we go. So now we have a base material that we can use for whatever we need. So just right click this, create material instance, and now we have a player Canon matte. Alright. So player Canon matte's going to look a bit different. We're going to change the base color to sort of a gray. I think that'll work out. Yeah, that looks nice. Metallic, we'll set that to 1. We'll make it nice and metal-like. There we go. So the metal does, it sort of adjusts the reflections quite a bit. roughness. Well, what happens if we... Ooh, wow, that looks really shiny. Let's do, we don't have much in terms of the shininess, so we'll do, say, like 0.3 or something. There we go. And specular, let's lower the specular to 0.5. Let's lower the specular to 0. Okay, specular's not doing anything. I think oh wait, yeah, probably because metallic. Okay, there we go. So we'll do 0.8 or something. There we go. All right, 0.5. There we go. Yeah, looks interesting. All right, now we'll go back into our player character. So player, base player. There we go. We'll go to the viewport. We'll set up the materials here. So grab ourselves material, player base mat, and player can mat. Oops, wrong one. And then we go to the weapon actor. Click that button to go to the actor itself, and we do the same thing. We need to change the color of the cube. Alright, content, materials, player. There we go. So click compile. And then it doesn't show up. There we go. Took a while. There we go. Now we can better see the player better. We can see the cannon more clearly. Oh, the cannon's clipping out a little bit there. It shouldn't be too hard to fix though. And we definitely want to fix that though. So while that compiles, we'll just take this here, or this cube, and we'll just scale it down a little bit and then move it back a little bit. Oh, that's too much. There we go. That should do it. All right. So there we go. I'm gonna remove this print statement because we're no longer debugging the rotation necessarily. Let's get started with our next thing. So, okay, one thing to quickly check, what mode are we on? Okay, let's do client. Let's see how good our server code is right now. Ooh, that's not good. Not good at all. It's gonna be something we're gonna have to fix. So we're gonna do that. We can do that later on. We'll do that like probably next week. Anyways, time to shoot stuff. So, alright. So we're gonna go back into here. Let's make it a prop here. So we have weapon actor. Gonna do shootables. Shootable. So this is actually a sort of structure that I'm using for laser tag. We're going to be doing is we're going to start with a base class here. Shootable base class. There we go. So this will be just the actor that represents anything that we can shoot forwards. What we're going to have is we're just actually make it empty. Alright, so in case we ever want a different type of projectile or something like that, we could do that. Or if we want to implement lasers, then the purpose of the shootable class is so we can do that. We can do lasers, we can do projectiles, we can do, I don't know, confetti or something like that. We can do spray paint. Not. Going a little bit extreme there. Anyways, what I did right here now, we're going to be doing base projectile. So what I did was I right click, create child class. Now this child class is going to have whatever we put into the blueprint of this class. So let's say, I don't like the scene root. I don't really like, we can't delete that. Okay. That's one issue with child classes. So instead, I'm going to be doing something different. We're going to delete that. We're going to force delete it and keep base projectile. What we're going to do is instead blueprint, nope, not that, down here in this blueprint right there, there we go. Blueprint interface, we're going to be doing this instead. So shootable interface. If you're doing in C++, that'd be called iShootable interface, by the way. So what the interface does is it allows us to make different objects identifiable as certain things, pretty much. So let's say, well, yeah, I got this watch here. This is my watch. It's a smart watch. And it can implement the interface touchable, let's say. This pretty much says that I can touch the screen of the watch, so I can do that. Oh, what did I just do? Oh, that's a pin. So I can touch the screen, I can fill out the pin and whatnot on my watch because it has a touch screen. And then I can do the same thing for my phone as well. So my phone right here has a little Stream Deck application. I can touch it to do stuff like, switch over into the app view and whatnot. So the interface would identify the watch and the phone as being able to be touched pretty much on the screen, have a touch screen more or less. And then what I can also do is I can say cast from to the touchable interface, and I can call a function like touch on the screen here or something like that, or get the screen size, for instance. So that's what an interface does. And that's what we're going to be doing with the shootable as well. So we have a shootable interface, though I don't think I need any functions. All I just need is really the interface itself to identify if whatever the player collides on is a shootable at all. So we're back at the weapon actor. No, we're not at the weapon actor. Actually, wait, hold on. Nah, it's fine. Never mind. All right, we're gonna go back to the base projectile here. There we go. Go up to class settings right here, and then interfaces right here. We're gonna add our interface that we just made. So that would be the, I forgot the name. There we go. Shootable interface. Yes, of course. So search shootable interface. There we go. Compile. So now we have our shootable interface. So let's add something that we can see now. So there's a little ball. Let's see, to reset the collision channels, we did not do that. Huh, okay. We're going to be doing, we'll do that eventually, but what I want to do is, so we'll set this here, collision presets, set this to a physics actor. This doesn't mean that it's going to be like affected by gravity or anything like that. It just means that it can move around pretty much. But the collision preset, if we expand this, it identifies what we're going to collide with and how we're going to collide with it. So specifically, we're interested in the pawn because that's the players, and it's going to block against the players, so it's just going to like bounce off them, or it's not going to go through them or anything like that. But what this will also do is, right there, we're going to check that simulation generates hit events. So to detect a collision with the player, actually, we can do that right now. So if we go into the event graph, you can right click over here. There we go, event hit. Here we go. And then make sure here, okay, let me check here. Okay, we have a collision check, so we did a separate it's a separate capsule with the collision check. I don't think we necessarily need that though. No, actually I believe that was, okay, let's stick with the collision check of the capsule. So collision check, we have that selected. Make sure this also has generate hit events on. So the event hit is, you can read about it more on the official documentation, but pretty much in a nutshell, we have my component. So the component, so this would ideally probably be collision check. Maybe it'll be sphere or the weapon actor. That's the component that's currently owned by the object that gets hit. The other is an actor. So this is the actor that gets hit. So it would be our base projectile. We can take other and we can cast to shootable interface. There we go. So if base projectile hits our character, then it will run through this code here. Otherwise, it'll go through the cast failed. We could also do, you can just do implements, does implement interface, and then select our interface, shootable interface. There we go. We could do that too. But because we only have like really one thing going on with the hit, we'll just stick with the cast and also help out a little bit. All right, and then next up we have the other component. So if we look at the base projectile, this would be probably the sphere when it collides. Sometimes it could be null depending on how the. Actually, I don't think it can be null. Yeah, it really depends on what the actor is. And then self-moved, I believe, probably indicates if the collision resulted in the actor moving in place or something like that. Not entirely sure. I think that's something that's more or less new, but all right. And then moving on, we have the hit locations. This is in the world. Where does it hit? Pretty much. The hit normal. So relative when it hits on some sort of surface, what is the normal direction of that surface? So this is good. This is useful for when you need to calculate a reflection angle, pretty much. And we'll probably actually be doing this in the base projectile. And then last we have the normal impulse. So this is accounting for the physics of the object that's hitting. What is the resulting impulse that would be applied when the object like bounces off of the collision? And then last but not least, we have the hit result. So this is pretty much all of this information and also quite a bit more as well, all within a struct. So a struct just holds all this data nice and conveniently. We won't be worrying that much about that. So with this here, event hit, cast is shootable. Let's do a test, print string, hit by shootable. Yay, nah. There we go, little test there. All right. So now back to our base projectile. So I have a sphere here. We need the sphere to move around. So if we look back here, we added a floating pond movement back when we were setting up the character. We could do something a little bit different, but a little bit still similar with our projectile too. It's a, there we go, projectile movement. Let's keep the default name there. All right, let's see here. So with the projectile movement, what we can do is set up an initial speed and max speed. Let's see here. Let's do max speed of 1,000. We'll also make that the initial speed. So when you shoot the projectile, it'll be going as fast as it can possibly go. All right, what else we got? So I want it, yeah, it should bounce. We want it to bounce off the walls. And something, a little bit of a physics lesson here. So the bouncing effects, we're going to go to the true thing. Okay, so this is when you're bouncing an object off of a surface, depending on what the angle is, the amount of friction applied to slow down the object could vary. You won't want that because that just sort of complicates the movement. Bounciness, we're going to set this to 1. So the bounciness is how much velocity is lost when the object bounces on something else. Then we got the friction. Friction is not related necessarily to bounciness. Actually, no, it is. So when you have like a bouncy ball and it bounces onto a ground and then starts rolling on the ground after it's like, done bouncing continuously, the friction indicates how much of that sort of rolling movement is lost every single time it bounces. So we don't want this projectile to be like stopping every time it like hits the wall pretty much. All right, and then we can just keep that the way it is. Let's look at what the other settings we have. So projectile gravity scale, we'll go with, oh, that could be interesting. Yeah, actually stick with 1. All right. Some of the other features we got, force substepping, so that's just a simulation optimization sort of thing. We can just keep that on default. Objects moving straight, you truly do not need to set this as maybe always. So we have simulation under gravity, so the sub-stepping will pretty much be working. We want the collision to be sweep. We want simulation to be enabled. That way the ball, moves. And then we also definitely want the collision to be sweeping. So this means that it will check within the range that it moves between ticks, whether or not collided. And this other stuff has to do with how it simulates, in terms of like the physics and also the collision and whatnot. And then this stuff here, that's just standard for a component. Starting with ticking, and then there's also probably any replication or something like that. Not too worried much about that. Then we can make the projectile homing, which is actually a really easy way. In the blueprint code, you specify a target, and then you also set this acceleration magnitude. The more acceleration it has, the sharper it'll turn towards the target. But it's just a nice and good way to have a projectile actually follow something else. All right, and then we have interpolation. So I believe interpolation okay. So the interpolation is when usually you set like a minimum and a maximum, and then you have a value. So in this case it'll be the times here, the rotation location time. You have a value which determines where the ball is between the minimum and the maximum. That's what interpolation is. We don't need that, though it could be used for some interesting stuff. Like we could have the ball shoot forward and then it pull back towards the player. Sort of like if you like, I don't know, play Overwatch or something, like a Roadhog's hook. That could work sort of like the projectile movement. Alright, and then velocity, we have an initial velocity here. So we can set this just to our initial, yeah, we can just keep this as default actually. What else we got? We got planar movement. So if we want to restrict the ball, some movement, so we could constrain to plane, and then let's say constrain it to the z-axis plane. So this will prevent the ball from moving along the z-axis. So it'll just move in a straight line across the X and Y. It won't go up or down. We don't need that though. We don't actually really want that really. Alright, and then that's pretty much everything else for the projectile movement. Click compile there. Now, one thing about the bounciness from the game design that we have here. So, small projectiles that bounce off walls. I want to set the maximum number of times the projectiles can bounce off the wall. So we're going to do an event hit like before. Back here, we have the shootable interface here. One thing I am going to do, we're going to destroy this. So actually, can I do it from here? Destroy, nope, okay. So we're going to take the actor reference, and we're just going to do destroy actor. Because we only want the projectile to hit one person, pretty much. I don't know, maybe we could change it so that it can hit multiple people. But for now, we're just to have to destroy when it hits a player. Anyways, in this event hit, so let's see here. We're going to have a bounces left variable. So over here in the variables, bounces left, we'll set this to an integer. We'll make it under category 2, so default and bounces. There we go. Now it's under the little category, just for some organizational purposes. No, not really that important. All right. Replication. We'll have this replicated. Yeah, sure. Why not? And actually, no, we don't need it replicated. All right. So let's compile, and then right here we have bounces left. So let's set it to 3. I think that's a good number. So what we're going to be doing is, let's do a branch here. Here we go. So check if bounces left is equal to 0. If it is, we will destroy the actor. Destroy actor. Otherwise, then we will take bounces left and we'll do decrement. So this is a shorthand to subtract 1 from the bounces left. Now, one more thing that I'm going to do. We're going to look into a little bit of Niagara VFX probably today, actually. That'd be fun. We're going to do on destroyed. Let's see here, event destroyed. There we go. So we're going to keep this here for later. We're going to spawn in a little destruction effect that spawns in when the our projectile gets destroyed. You can also spawn a little shooting effect as well. We can do that. All right, so let's see here. We have our projectile event hit, finally getting bounced. We have the event hit for the player as well. What we need to do is have the player actually shoot. So the best way to do that, start off with an event tick. No, not event tick, custom event. So custom event, there we go. And then shoot underscore server. So this will shoot on the server. It'll spawn the actor on the server. Now let's go back to our base projectile, and we need to make sure that replication is on. Without replication, we won't be able to see it. So let's set it to always movement. We'll also replicate the movement. Let's set it to always relevant because we want to make sure that every single projectile is accurate, pretty much. And turn on replication there. Alright, anything else? I think that's all good. Then we go over to the sphere here and we make sure that this component's replicated as well. Not actually the most important, but you know, just in case. Actually, no, we won't replicate the sphere. I don't think we need it replicated. Alright. So now, actually, if we add it in, there we go, there's our base projectile. Make it a little smaller now that I can see the world scale. So I have over here my side window, and let's re-add the base projectile, so it's a big projectile. Make it a little bit smaller, so I think I'll probably 0.75 scale. Make it uniform. There we go. Alright. And then let's assign some sort of material to it so that's not difficult to see. So new folder, props. And then actually, so this material here, I'm gonna go to window, constant browser. I'm gonna just get another constant browser over here. There we go. I'm gonna make a folder, a different folder, call it base. I have been not obeying my naming schemes. Oh well. Just do that real quick. Let's ignore that. Okay, base. So I'm gonna move this player base mat over to here, and then just rename it to base mat without the player part, just because this is like the basic material that we can use everywhere really. We could even use it for the map materials, but I think we're going to keep that the way it is. Alright. So we have a base material now. We're going to create a material instance, and then call it projectile base mat. There we go. Over here, props, move this right there. Alright. Now we save all. And then one more important thing to do, right click this, fix up redirectors. So this will just help us make sure that cleans up any extra unnecessary files that might be left behind after we move stuff around. So fix up redirectors. I think we're all good though. Yeah, alright. So projectile base mat. Let's I'm thinking emissive actually. Set the emissive brightness to, let's say, 10. Emissive color. I want to go with the green. Ooh, wow. So that's what the emissive does. It's pretty bright though. Looks pretty cool. Let's see what it looks like in the level now. Oops. Okay, let's see what it looks like when I apply it to the base projectile. So here we go. Pile, and then turn on lit mode. Oh wow, that's pretty difficult to see. But wow, that actually is kind of neat though. Let's take that directional light there. We'll tune this down a bit. There we go, that looks a bit better. Also make it a little bit smaller too. So base projectile. This, by the way, changes the default scale, in case you're wondering. So there we go, 0.5. And then, just for a little bit of optimization, we'll find the shadow settings down here over in rendering. We'll just turn off shadows because I don't think we need shadows on the projectiles. So let's see here. Where is it? Hold on. Cast, contact shadow, static shadow, dynamic shadow. Turn off dynamic shadow. Turn off cache out. There we go. Okay. Alright. Now, we got our little base project. Nope, we don't have the material. It's blueprints, props, shootables, base projectile. There we go. Now if I go into object direction mode, we can set the direction. There we go. So now if I click simulate, it should move. There we go. Oh. There we go. Let's retry that again. Let's add a few more actually. There we go. Alright, click simulate. There we go. Let's make the bounces a little more. Do 10 bounces just for testing. Good to test out stuff with sort of extreme values. There we go. That's actually pretty interesting. I like that effect. Let's look at it again. See it like bouncing up and down. Alright, there we go. So now we just need a player to be able to shoot them. So we have shoot server. What we want to do is we're going to stop this, and what we're going to do is we're going to take the weapon actor and we're actually just going to get the class. Get child actor. There we go. So this is just an actor reference. We'll cast it to our base. Cast it to, what will we cast it to? So blueprints, player. No, blueprints, props. There we go. Weapon actor. Let's cast it to a weapon actor. It's always going to be a weapon actor, so I'm going to use a pure cast. Then we need to actually implement the shooting up in here. So another custom event. Shoot server. Alright, and then here, make it run on server, reliable. Spawn actor from class. We'll select our base projectile class. There we go. Get the emission point. World transform. Get the world transform right there. The instigator. So let me just double check here that we have the owner set of the weapon. So I think we need to do that. Yeah, we're gonna need to do that. So gonna add new sequence here. And let's comment this out a little bit. So we'll drag this out here, drag that out there. This is set the sphere scale. There we go. And then drag something out here. We need to get the weapon actor and set hold on, I got a better idea. So on our event possessed, right here, open actor, set owner, set instigator. Can I not set? Okay, fine. So set the owner of this to get owner. There we go. Alright, so what this does, we need to make sure that this owner is set for two reasons. One, we're going to be using it as this instigator here. So if we get the owner, get owner right here, and then we need, what do we need? A pawn object reference. So we'll cast this to pawn. Actually make it a little bit different here. We're not going to be doing that. Or will we? No, we will get the owner of the owner. So get owner, this will be a on. Get owner, this will be a controller. So that's at the owner. Cast upon, so that's the instigator. We'll convert this to a pure cast, and then we need to change this rather than get owner. Self. Get reference to self. There we go. Alright, so two reasons. One, now we have an instigator field set, so we know who is the one who shot the projectile. And then two, the owner is important to manage for multiplayer because it indicates when something executes on the server, who runs it versus who runs it when it's running on client versus multicast just runs on everyone. Alright, there we go. So now, back to our base player. Let's check our project settings here. There we go. Check that we have, no, not the project settings, sorry. Old system. We need to check the input. Over here in blueprints, inputs, and then we'll just check our test input mapping. There we go. Player movement, player looking. Okay, looks like we need to add some more mappings here. So we'll do right here, input action, player underscore shoot. Alright. Make it a digital boolean. Now, one thing to note on mobile is that this player shoot will just be whether or not the player is touching the screen. It's a little bit different on, say, keyboard, mouse, or controller, where you can have a single button separate of where you're like aiming to shoot. Anyways, so I think that's all good. We don't need to do anything else that's fancy with that. We don't need any sort of modifiers. So we add here, right here, player shoot, and then we'll set the default key. Just click that button right there, and then left click. There we go. You have it set to the left click now. The player map ability will not worry about that for now. Alright. Alright, I think that's all good. So then we go back to our player actor here. There you go, player looking. And make sure you comment this out. Player looking. There we go. And then right over here, player shooting. Alright, so now we are player underscore shoot event here. So one thing I do want is continuous automatic firing. So let's see here. Let's just shoot right here, ongoing. Shoot server. Alright. And then from the shoot server, we have the weapon actor here. We need to do the same thing, shoot server right there. Now this here, I'm gonna actually make this a little bit different. So actually let's see what this does. So if I click, not simulate, if I click in the selected viewport, there you go. Aha! Haha, it doesn't do anything. Okay, let's look into that. Make sure that this is running. Aha! So that's the issue. This ongoing isn't doing anything. Maybe we need to have a modifier for ongoing to work. No, it doesn't look like it. Okay, so we're gonna have to do something a little bit different. That's fine. So we'll still call shoot server. We will actually add an input. Shoot start. There we go. Let's make sure that it will trigger when we release as well as press down. Okay, it only does it when we... Oh boy. So we need to also do it here as well. There we go. So as you can see, got quite a few projectiles going around there. Also, the scale of the projectile is a bit wonky. Yeah, let's fix that. Okay, let's fix first. So right here, transform scale method. Set that to override root component scale. That should fix the scale of the projectiles. Never mind, didn't do that. Okay. Ooh, so many. Ah, yes, I know why. Alright, so break this link. Split this. Split this. So we want the location and we want the rotation. We want the scale to actually be scaled. There we go. Ooh. Okay, one thing I noticed is that the balls... No, they're going in the direction. Okay. Anyways, let's fix that now. Okay. So anyways, look here, there we go. We have shoot start, whether or not it starts shooting. I think we can actually just probably ignore that boolean. Now we'll do that little check there. I thought it was going to be used for something else, but we're not. So what we're going to do instead here, put that into a comment, shooting, there we go. I'm going to do a timeline. Timeline, shoot timer. Hold on. I'll make this a little bit different. So event tick sequence. Alright, so shoot server is that. Okay. Right here. Make sure that we only run this on the server. We're going to add a timeline here. And make it the shoot timeline. There we go. Add a boolean there. We're going to make a boolean here. Shooting. There we go. And make it properly named too. So properly in Unreal Engine is B shooting. Just like that. Okay, so anyways, if it is shooting, then we're gonna do this a little bit of a complicated way. So do once, there we go. Go to play, and then hold on. Play, update, finished. Okay, there we go. That's actually simpler. Make this be custom event. Spawn projectile. We'll also make sure it's only running on the server. And then shoot underscore server will actually set our B shooting value. Gonna add a pin there. And then spawn the projectile. Break that link because that's an old link. And there we go. Now one more thing that we need to do, we'll go back here. We need to pass this over into there. So actually I can change this up. There we go. Alright. There we go. That should be able to get us a little bit of better pacing. So let's set up the timing for our shooting. So let's say every 0.1 second. So just set the length to 0.1. We can add length to add like add a track. I mean, yeah, she also had a track. So add a float track and just call this time. Gonna add a key there. Just make it 0, 0, and then right here add a key. So time will be at 0.1, and we'll make it 1. So that value is 1 at the end. We can use that if we need, but we don't need to. Alright, let's see how this looks now. Sure, it should still be fairly rapid fire. Oh boy, that's very rapid fire. Alright, let's lower that again a little bit more. So let's try 0.5. Let me change this to 0.52. Change the value to 1. Huh, I didn't notice that. Okay, there we go. Oh, that looks better. Alright. Hold on. Sorry, I'm looking at... Oh, that'll work. No, okay, that won't work. Tasks. timer. Okay, that'll work. Okay, set timer by event. We'll make this into an event, or rather we will get an event. Spawn projectile right there. That didn't work. Okay. Oops, I selected too much. Alright, let's move this up here. We'll do it in the event begin play. Put that to a variable. So that will be our shoot timer. Timer. Oh, looping, turn that on. Okay, spawn projectile. Alright. Every 1 second, loop that. And then false, we need to clear timer by handle. So there we go. That should do it. That didn't do anything. Okay, let's see here. We need to fix this. So first off, let's remove those print statements from before. I don't like them there. There we go. Okay. Compile. Now if we go back here. It's not setting a timer. Hold on, let me do this the manual way. It's gonna look a little bit ugly. So rather than using the create event there, I'll just manually add the event. Alright, now let me see here. Let's add do once. Make sure we only set the timer once. That might help out. Oh, there we go. Now I have a little ball. Alright, let's change it. Let's add one more thing here. We'll call the event spawn projectile. The first thing. And then change this to more like 0.1 or something. There we go. That looks better. Alright, one thing I'm going to do. As you can see, when I spawn in the balls, they aren't... Okay, there's a few things I'm going to change up here. So we make this like, 0.25. Just make it a little bit less. Make it the scene root too. I'm not sure why it's not the scene root. Wait, no, I'm not that. Oops. This here. Okay, so we're going to actually turn on shadows. Cast shadow, yeah. Cast dynamic shadow, yeah. Should help out a little bit with seeing the balls. Alright, and then one more thing we're gonna do. So on our base projectile, let's go into the construction script. We're gonna add, can I add a local variable and then make it visible by default? No, I don't think I can. Okay. Gotta have an initial velocity. Make it a vector. Set it to init. Compile, and then projectile movement. Set our velocity. Make the initial speed that max speed. We'll make it much larger. Don't worry about the max speed. So set the velocity to the initial velocity plus the forward vector. Get forward vector. No, not that. We need the actor forward vector. That one there. Okay. Get actor forward vector times projectile movement. Get the initial speed. I guess I could do, is there like an inherent speed? Hold on. No, there isn't. Okay. So multiply the initial speed times the forward vector of the actor and set that to the new velocity. So there we go. Compile that. And now if we click play, that didn't work. That didn't work because we didn't set the velocity. So this initial velocity, what we need to do is expose on spawn. Instance editable. Instance editable. So that what that will do is now if we go back here to our spawn base projectile, we see we need to refresh this node real quick, and then we see the initial velocity. So what we can do is with our emission point here, we can get the velocity of this point. So get component velocity. That's just a nice convenient function to get the real world velocity of the component or something. I don't know. And now it still doesn't work. I think it's still going only in the X direction. Nah, it doesn't do it. It does it that way. Weird. Okay, back to our projectile. I think there's something different. So, the initial velocity is, I believe, relative to the object. That means that x is the forward direction. So then what we need to do is get the relative initial velocity. What we need to do is delete that and then set that to 1. Nope, not quite, not quite, not quite. So let's make sure that that initial velocity is being set. No, it's not. Okay, so that's the issue. We don't have an initial velocity. Alright. Alright, alright. So, I still want the velocity of the end of the weapon, though. Because that could create some interesting things. You could probably... Ooh, that'd be cool to have like a curve with it. So anyways, this component velocity only works if the body is simulating physics. So there's the issue with that. We can try, however. Okay, we need to just manually set the velocity. So we'll have a variable here. Call it mission velocity. There we go. And then default or tick, something like that. There we go. Okay. So on our event tick here, in second, we'll just now I won't turn our replication. Shooting tick, there we go. Okay, now right here, drag out of this. We'll set the emission velocity to the to the velocity emission point. Get the world location, and then we need actually previous velocity. So copy paste. Emission velocity, emission previous location. Okay, set this category to per tick again. There we go. And then we set previous location up to be that. We will also copy this actually to the event tick, just so that we have something actually event being in play up here. So we have something just at default. Okay, now emission velocity. So the velocity is the current location minus the previous location or final minus initial. Initial minus final. Okay, that'll work. If it's reversed, you can just flip it. And then we divide it by the time. So the time is the delta seconds right there. There we go. And then hopefully delta seconds is never 0, because if it is, then we're going to have, and yep, it look, okay. Hold on. So there we go. We got all that set up. Now down here, initial velocity, we just use the emission velocity. We drag that in. Hello. Compile that up, and now what's going on? Okay, let's re-add that print statement because I want to see what the velocity is to make sure it's all correct. So base projectile, print string, we'll print the initial velocity, save that. All right, there we go, okay. So if we move this around, as you can see, we have a velocity. If we hold it still and then we move in this direction, so looks like it's negative y, and relative to this, that looks like it's correct. This positive y, all right. What about this direction? So that's positive x. Okay, that looks all correct, so we don't have to flip it. Oh, thank you guys. Thank you everybody for staying by and watching. So I think we got a lot of good work done today regarding the ability to like our player abilities, specifically being able to like shoot the projectiles. The projectiles also bounce off the walls, which is really neat. I think next week we can definitely tune the projectiles a little bit, maybe add some like ammo or something like that. But that's something that we can develop over time. I think actually probably next week we'll start maybe looking into a little bit of UI. That could be kind of nice, or maybe going back and fixing up some multiplayer issues. Maybe we could start implementing basic AI. I don't know. We'll see. We'll see what where we end up next. But that is definitely something that we need to, some of the stuff that we need to do. So go over here. Oops, actually, yeah, let me go back into our main screen here. Transition. There we go. All right. To do next stream. So we did that. Done. So that's done. Boom. Build a basic level. Testing. Yeah, that's done. We got that too. Weapon shooting. We did that too. Fix showcase project. I still need to do that. Yeah, I forgot about that. Okay, let's see here. To do for next stream. So next stream. Focus for next stream. Let's say let's do network debugging and more ability implementation, like ammo, something like that. And then maybe also AI, who knows? Probably not quite yet. Basic game mode, and then also we need UI for that. So yeah, there we go. All right, I think that's a good overview for next week, and you gotta remember me to actually look at this next time because I forgot to do that. Anyways, so yeah, that'll actually be it now. So be sure to follow and subscribe for next week. Hopefully we will be doing this again on Wednesday because I think it's better for everybody to be doing it here now rather than late at Saturday night. If you're curious, by the way, I'll probably be going back to playing games over on my personal Quantum Quantonium channel on Saturdays now. And we'll stick with the Wednesday live streams here for the game development. Also, I hope to be showing you guys some more of the amazing work that's been going on with Project Laser Tag, and hopefully within the next month or so, be announcing hopefully playtesting for Project Laser Tag. So that'll be definitely exciting. Saw some of the C++ code that I've been working on. So if you want to know how more advanced Unreal Engine works, you can look earlier on at the start of the stream for that. Anyways, so yeah, be sure to check out the links there, all of that stuff. And I guess I'll see y'all next week for part 7. All right, sounds good. See you. So let's see here. There, goodbye.